this so I could post it. The first thing, okay, there's going to be a lot of questions that ask you if it's linear, exponential, or neither. Okay, so there's different ways they could ask this to you now. Okay, they could give you an equation. All right, if it was an equation, linear equations would look like this. mx plus b. Another way to remember when equations are linear or not is the biggest exponent is a 1. Okay, so obviously you can't see an exponent here. That's because we never write anything to the first power. We only write it if it's the second power up. Okay, so those are two ways of remembering like whether an equation is linear or not. All right, exponential equations, they kind of look like that. Another way to remember it is there's an x in the exponent. All right, and then if it's anything other than that, it would be neither. Okay, so an example of a neither would be like something where there's an exponent that's bigger than 1, but it's not an x. Okay, so something like this would be neither. It's definitely not this because the biggest exponent is not a 1, it's a 2. And there's no x in the exponent. Okay, so that's an example of neither. This would be an example of a neither. Yeah, it's pretty much the only ones you're probably going to see. Questions so far? I'm recording this too. I'm going to post this on YouTube, just so that way you guys can look at it when you're doing the study guide. All right, so those are equations. Now, don't erase yours, just write underneath it. Okay, they might also give you a graph. Okay, graphs are usually the easier ones. Linear graphs could look like this. They could look like this. They could look like this. They're basically just straight lines. Okay, exponential graphs are the ones that's bad. They're flat on one side, and then they go up on the other side. They could be flat on one side and go down on the other side. It could be like that. It could be like that. Okay, but anything that looks like that, those are exponential. All right, and then the neithers is just pretty much anything else, like none of the above. So you might see something like this. That would be a neither because it's none of those two. You might see something like this. That's definitely a neither. Okay. So those are like graphically, that's what they would look like. Okay, and then the last thing that they might give it to you in tables, which is what you're probably like most comfortable with. I like the tables the most. But remember, linear means they're adding or subtracting. So that would be a table. I mean, there's a lot of different options. But this would be linear. Okay, because they go down by 2 every time. An exponential one, remember that's multiplying or dividing. So maybe like 3, 6, 12, 24. Here we're multiplying by 2. So that's how you know if it was exponential or not. Just checking the chat here. I'll put it back up. And then neither. Okay, again, neither is like none of the above. So So maybe I start by adding 2, and then I add 3, and then I add 4, and then I add 5. Okay, so we're not adding or subtracting by the same thing every time. Remember, it's got to be the same number. And we're not multiplying or dividing by the same thing. So this one would be a neither. There is a pattern. Like there is a way to figure out what's going to come next. But it's just not this one, and it's not this pattern. Okay, it's a different kind of pattern, which you're going to learn about next year. Questions so far? I know I'm going kind of fast. We've talked about all this stuff, so I just want to make sure that I tell you, and you have this recorded so you can look at it. All right, so you're going to have to do that. Okay. Then you are also going to have to tell if it's continuous. Whoa. Why does that look weird right now? Is that how you spell it? I don't know. I think I spelled it right. It just looks weird. Continuous. If I'm wrong, someone correct me. I knew I added an extra U. Continue. That's right. I don't know. Doesn't matter. You guys know what I'm saying. Continuous. Okay, so I hate when that happens. Okay, so continuous, remember, this is if we can put anything in for x. Okay, so like an example of this was like water flowing. Okay, remember inputs would be like the time. Okay, and like for any amount of time, there would always be some kind of water flowing if it was like a waterfall or something. If it was a faucet, so we'll put that. We'll put example, we'll put waterfall. And like, I understand if there's a drought, it would stop. And I understand if it like freezes, it would stop flowing. But we're just going to assume that the weather's always nice, 75 degrees, and it's flowing. So a waterfall would be continuous, okay? Something that's discrete would be like a sink. Like a kitchen sink. Okay, because the kitchen sink, you don't leave it on running every second of every day for your entire life. If you did, it would be annoying, and you'd probably waste a whole bunch of money on your water bill. Okay, so this is when, and like the word description for it is when we can only put certain things in for x. So like what we're talking about here is like there's only certain times when your kitchen sink would be flowing with water. There's only certain times you could put in where if you like took a picture, there would be water coming out of your sink. But if you think about a waterfall, you could go any second, any time of the day, any time of the year, if it's not frozen or dried up. And whenever you took a picture, there would always be water flowing. Okay, so that's what makes something continuous. No, I'm recording this. This is going to be a YouTube video, so I'm going to put this whole thing onto YouTube instead of onto Canvas. I don't know why, I just did it that way on accident. Okay? So now that's another thing you're going to have to do. Linear, exponential, continuous, discrete. Okay. You are also going to have to write equations, which we've been doing that for the whole year, in slope-intercept form. Okay, there's two forms of an equation that we talked about. Slope-intercept is kind of like we reviewed it. You guys have already done that a million times. The other one was the one if you don't have the intercept. That was point slope form. Okay, so slope intercept form, okay, this is what you're going to have to be able to do. All right. I'm going to tell you, like, slope is 7 and the y-intercept, and you might have to look at this on a graph. One second. Okay, so they might tell you the slope is 7, the y-intercept is, I don't know, Leslie, what's your favorite number? 5? Cool. So the y-intercept is 5, and you're going to have to make the equation. You're going to have to write it. Okay, so remember, it's y equals mx plus b. You just have to remember that the m is the slope. Okay, so I'm going to put that here. M is the slope, okay, and b is the y-intercept. So we're just subbing it in. Whoops, let me admit someone here. For those of you guys that are coming up late, this will be up on our YouTube channel. This ain't the Math 2 playlist. Okay, so you would just have to plug them in. Change the m to a 7, change the b to a 5. Boom, slope-intercept form. Okay, so again, like they might not tell you in words, they might give you a picture of the graph and you might have to write the equation. Okay, but again, all you need is the slope and the y-intercept. Okay? So for the other one, okay, for point slope form, that's the one where you need the slope and then any random point on the line. It doesn't have to be the intercept. Okay, so here I might tell you, okay, the slope is, Brian, what's your favorite number? A 100. Nice. I've never heard anyone say that their favorite number is 3 digits. I like that. So slope is 100. Ricky, what's your favorite number? What's your football number, Ricky? 53. Okay. I like it. So we'll say, okay, I need one more. Because for this, remember, it's a point and a slope. So our point will be 53, comma, Maya. What's your favorite number, Maya? 3? Yes. It's mine too. Okay, so point slope, okay, point slope form means I'm going to give you a point on the line. I'm going to give you the slope of the line. And we should be able to write the equation. Okay, and I'm going to show you how. And we already did this, but this is the form of it. Okay, so again, if you don't have this written down, it would be a good idea. We've done this already. We did it once, so we didn't do this a whole lot. We did it we spent one day on it, I think. Okay, and so the m, okay, that's the slope. Obviously, that doesn't change. The m is the slope. Okay, but then there's an x1 and there's a y1. And those are the coordinates of your point. So the 53, that's x1. The 3 is y1. Okay, and now we just plug it all in. So it's going to look like y equals 100 times x minus 53 plus the greatest number in the world, 3. Okay, so it's just another way to make an equation of a line, a linear equation, when you don't have the y-intercept. Like maybe you just have a point on it and the slope. Maybe you don't know what that is. Whoops. Maybe you don't know what that is. Yes. This is only for linear. Yep. Good question. And exponential we pretty much just do it the same way as those explicit equations. So it's like the first number times the pattern to the x minus 1 power. I don't believe there's any exponential ones on your test, but let's do one real quick, just to review, because we're pretty much done now. All right, so exponential, say this was our list. Say we had 5. No, we need a table. So remember, the exponent is always x minus the first x. Okay, so I'm going to try to mess with you guys here. Okay, so we'll start with 1. No, we'll start with 2, and then we'll multiply it by 3. So we'll go 2 times 3, 6, 18. 18 times 3, 54. Okay, so this one is times 3. Okay, so this is how we make equations for exponentials, and there's only really one way we do it. First number goes first, and then we make the pattern next, and then the exponent is always x minus the first x in the table. Okay, so that number is the first x in the table. This number was the pattern. I shouldn't have probably used 2 3s right there. It's kind of confusing. All right, and then this is just the first y in the table. So we got first y times the pattern to the x minus first x power. Just in case you need to do one of those. Good question. And don't forget too, like anything that you're doing on this test, we've probably already posted videos about it or in other Zooms. So if you want to go back through the YouTube playlist, you might be able to find some other, like there's a bunch of exponential explicit equations and linear explicit equations. So, all right, good. Last thing, I just want to remind you of the percentage problems. Okay, percentage problems. And it's actually probably good you asked about the exponential. Because percentage problems are always exponential. They're always multiplication. If you think about like how you find a percentage, it's always multiplying. You always multiply. Okay, so there's 2 ways that they could ask you this, okay? You could be gaining a percentage. Okay, say we're getting, I don't know, 25% every month, and we start with, I don't know, $500. All right, so maybe like your parents, like you got $500, and they say, okay, well, if you get like straight A's, you know, for every month you have A's, we'll give you 25% extra. Okay, so what we just talked about, okay, all we need is the first y, which is going to be this. Okay, so for this, if we wanted to make this equation, okay, we would start with 500, and then we're going to multiply, okay, because it's a percentage. And then, okay, now remember, if you're gaining 25%, what we need to multiply by is actually that. Okay, because, yes, the start is a key word, yeah. Yep. That, though, yes, that's actually where I was going next. The start means that we started at 0, right? Because when 0 months pass, we'll have an amount of money in there. It'll make sense. Okay, before 0 months, before any months of school go by, we're starting with 500. So what that means is that the exponent is going to be a minus 0. In other words, it's just going to be an x. Okay, and the reason it's 1.25 is because, remember, 25% is what we're gaining. That's how much more we're getting. But we'd have to take that 25%, whatever it was, and add it back to our original amount, which is 100. Okay, and 100 plus 25 would be 125. So technically, every month, if you're gaining 25%, you're actually going to get 125% of whatever you had in last month. Meaning the 100% you already had, so like the 500, plus whatever 25% is. Okay, so if you're gaining money, you add it to 100. So it makes it like 1.25. Okay, now I'm just gonna erase this. You guys can rewrite it if you want. Okay, but I'm gonna change this now to losing 25%. Okay, because you might gain some money or you might lose it. It might not be money too. It might be like, amount of bacteria in your body or something. Okay, like as you take the medicine from the doctor, the amount of bacteria drops by 25% every day or something. All right, so this is the important part. Right here, we were gaining, so we added 25% to 100. But we can't do that right now because we're not gaining anything. So what we actually have to do to figure out what we need to multiply by, we actually need to take our 100% and then subtract the amount that we're losing. Okay, 100 minus 25 would be 75. So 75%, that's actually how much we're going to be having the next month. So like the second month, we're going to have 75% of what we had the first month because we're losing 25. Okay, so when you write this equation, it would be very, very similar, except the 1.25 would just change to a 0.75. Because we're losing it. Yes. This is actually for exponential. Every time it's a percentage problem, it's always going to be exponential. So if you're gaining the percent, yes, whatever percent they give you, you're adding it to 100. Yeah. And then whatever percent they take away from you, you're taking that away from 100. Okay, so this part right here, like the 500 times whatever, that's just starting point and then the pattern. We know it's going to start with 500 because they tell us, and then we know it has to be times, okay, because it's a percentage problem. So all we really have to figure out is what we're multiplying by. They're going to give you the start every time. So we just have to figure out, are we like gaining a percentage of whatever? Are we adding it to 100? Or should we subtract it from 100? Does that make sense, Brian? No problem. And we could just write this down right here for those percentage problems, okay? And this is the last thing we're going to do, and then I'll let you guys work on that practice test. Okay, for percentage problems, if you're gaining, okay, then you add the percent to 100. Okay, but if you're losing, because that's how it's going to work. Whenever you have a percentage problem, you're either going to be getting something or losing something, or like paying something. You might be like paying interest or something, which means you're going to be losing money because you got to pay someone. So if you're losing, you just subtract whatever percentage you're losing from 100. And it's always, remember, always multiply.